Have you observed that when one is very hungry, on the sight of food, he salivates and tends to eat more? Have you also observed that when a car is traveling faster, it takes less time to get to its destination? Have you also observed that when a stream or river gets too warm for aquatic life, the fish or other organisms tend to migrate to cooler waters? These three examples are talking about one thing: variation. And that is our topic for today. Yes, variation occurs in everyday life. Before we delve into types of variation, it is good for us to know the importance of variation and also some terminologies associated with this topic under consideration. Variation can help us to make good decisions, not just good decisions, well-informed decisions. Variations can also help us to predict outcomes, and it can also help us to optimize systems. There are some terminologies that are connected with variation. One, we'll be talking about variable. A variable, these are the quantities that vary with each other. Another terminology we will be talking about or we'll be using is sign of proportionality or sign of variation. This is very, very important because this is what relates the two quantities. Another one is a constant, K. There is always a constant which we must find. As in the second example that we gave, a car travels fast. It gets to its destination at lesser time. But the road, the distance it covers does not change. It remains constant. So there's always a constant in variation. This constant of variation we will find will lead to what is called the law of variation or law of proportionality. This is very, very crucial because it is with this law that we will find any other quantities that we ask to calculate. Let's now go into the types of variation. Types of variation. There are four types of variation. One is direct variation, inverse variation, joint variation, and the fourth is partial variation. We are going to discuss each type of variation, but we'll not cover all in this video. In this video, we are going to take one type of variation, which is the first one, direct variation. Now, The first type is something we see all around us, but sometimes we hardly take note of them. Let's give an example. A dimmer lamp. Not all of us will know what is called a dimmer lamp. The dimmer lamp controls the brightness of a bulb. If you put the switch in 1, the bulb is low, it's dull, not bright much. But if you take it to 3, you see the brightness increasing. If you take it to 5, it's very bright. That's one practical example of direct variation. Another practical example which we all know is our ceiling fan or standing fan or table fan. At 1, the speed is low. At 3, we observe that the speed increases. At 5, the speed of the fan is at its peak. That's another example of direct variation. Now let's look at some worked examples. How do we go about solving problems in direct variation? Let's look at some examples. 1. If y minus 3 is directly proportional to x squared and y equals 5 when x equals 2, find y when x equals 6. Now if you look at this example here, first let us identify the two quantities that vary with each other. Y minus 3 is one quantity. So y minus 3 varies directly or proportional to the second quantity, x squared. This is how you write direct variation. Y minus 3 varies directly as x squared. Now after connecting the two quantities with the sign of proportionality, the next step is to introduce our constant k. Well, by the time we introduce our constant k, this sign of proportionality will change to equal to. It becomes y minus 3 equal to k x squared. We now look for k by dividing both sides by s squared. If we divide both sides by s squared, we are going to have ks squared over s squared equals y minus 3 over s squared. Click here. So our value for k is y minus 3 over x squared. Y minus 3 over x squared. You may wonder, let me write it up again, just in case you can't see it there. So k will become y minus 3 over s squared. Let's go back to the question again. You observe that the two quantities, we are giving values for them. We are giving value for y and we are giving value for x. The reason is for us so that we can find k, to enable us find k. So we are given that when x, y is 5, when x is 2. So y is 5, x is 2. Let's put it inside this relationship now. K will be 5 minus 3 over 2 squared. 5 minus 3 over 2 squared. That will give us 2 squared is 4. 2 here 1, 2 here 2. So the value for K is 1 over 2. So we know the value for K now. After getting the value for K, we now obtain the law of variation. How do we obtain the law of variation? Do you recall that point where we introduce our K into the relationship? So we say recall. What are we recalling? That y minus 3 equal to what? K x squared. We now impute the value for K inside. That becomes y minus 3 equals 1 over 2 x squared. This is the law of variation. This is the law of variation. Very, very important. Now, after obtaining this law of variation, we are confident to find any quantity we are asked to calculate. We are asked to find y when x is 6. We are asked to find y when x is 6. Let me give you some few seconds to write it in case you are writing. So let's find y. So when y we don't know, x is 6, from equation start, which is y minus 3 equals 1 over 2 squared, that becomes y minus 3 equals 1 over 2 times 6 squared. That becomes 1 over 2 times 36 over 1. 2 here 1, 2 here 18. So this implies that y minus 3 equals 18. If we collect like terms, that will be y equals 18 minus 3 is here. When it goes over there, become plus 3. Y equals 21. That's the solution. So the value for y equals 21. So we take note of the steps. These steps we are taking is all the same when we are solving direct variation, joint variation, direct variation, inverse variation, and joint variation. In partial variation, there is a slight difference which we shall see later. Let's look at another example. Indirect variation. I guess we are finished writing now. Example 2. A solid sphere of radius 4 centimeters is of mass 16 kg or kilogram. Find the mass of the sphere of the same material of radius 6 centimeters. So the first thing, let's identify the two quantities. A solid sphere of radius 4 centimeters. So one of them is a radius. So let arrow equal radius. Then another one is of mass, 16 kilograms. So the other quantity is what? Mass. So what we have is that arrow is directly proportional to what? A mass. Let's follow the same step as we used in the first example. Let's introduce K. Arrow will be equal to Km. If we divide both sides by m, to find K, to now be what? Km over m equals arrow over m. M will take m, leaving us with K equals arrow over m. So we'll use this relationship now to find K. Now let's look at the first two sets of values we are given. We are given that radius is 4, mass is 16. So when arrow equals 4, m equals 16, put it here, K will become 4 over 16. 4 here 1, 4 here 4. So the value for K is 1 over 4. The value for K is 1 over 4. Having obtained this value for K, we will now use it to obtain the law of variation. Do we recall? What are we recalling? The point we introduced the K, where we have arrow equals Km. So it will now become arrow equals 1 over 4m. This is a law of variation. This is a law of variation. With this law of variation now, we can now obtain the quantity we are asked to calculate. What are we asked to calculate? Find the mass when the radius is 6 centimeters. So when m we don't know and radius is 6, let's substitute it inside this law of the variation. Now it becomes 6 equals 1 over 4 times m. This is the same thing as saying this is the same thing as saying 6 equals m over 4. By the time we cross multiply, or we multiply both sides by 4, we cross multiply or we multiply both sides by 4, that would become m will be equal to 6 times 4, which is 24 kilogram. That's the answer. 24 kilogram. When you are given a unit in the question, please, in your final answer, always remember to put the units in the final answer, as it concerns that quantity we are asked to calculate. So that is just it's as simple as that, how to solve direct variation. Like I said earlier, the same approach is used with inverse variation and joint variation. First, identify the two quantities, the two or more quantities. Identify them. Use the sign of proportionality first to relate them. Then introduce your K or your constant. After introducing the constant, you find the value for K. You'll be giving all the values of the quantity, the first set of values. You'll be giving all those values. The purpose of those values is to find your value of K. impute it inside the relationship, find the value for k. After finding the value for k, the next thing you do is to obtain the law of proportionality or law of the variation. We will record the point where we introduce our value for k. Write that relationship out, then instead of k now, fix the value for k that you have calculated for. After obtaining that law of variation, whatever quantity you are asked to calculate in subsequent questions, simply input it into that relationship and you get your answer straight, as easy as that. In our next video, we will be looking at inverse variation. But please, before we go, I would like you to do something for me. Press that notification bell so that by the time I post subsequent videos, you will get notified. Thank you very much for watching. I hope you love this video, and please like the video. Thank you very much.